Hello everyone. I hope you all are fine and doing well. I'm Poonam Sharma, your science teacher. Welcome you all another interesting session of Structure of the Atom chapter. Children, in previous class we have covered these topics. I have explained different models of structure of atom which was given by J.J. Thomson, Rutherford and Bohr model. We have discussed postulates of Bohr model, which is considered to be the best model related to the structure of atom. So this is the most acceptable model regarding to the structure of atom. According to this model, nucleus is present in the center and the electrons are revolving around it in particular orbits. And when they are revolving in particular orbits, they are not radiating any energy. So this was cleared by Bohr, which was not cleared in the Rutherford experiment. So these models I have explained, and this is the comparison of different models related to the structure of atom. Now in today's class, we'll do electronic configuration. As I told you, Bohr gave certain rules for filling the electrons in different energy shells. As you know, electrons are revolving around the nucleus, and when these electrons are revolving around the nucleus, they revolve in particular orbit. Or we can compare the structure of atom with the solar system, in which sun is present in the center and the electrons are revolving around it. So these planets are similar to those of electrons, and sun acts like the nucleus. So if we'll see the structure of an atom, as you can see here, nucleus is present in the center and electrons revolve around it in particular orbit. These are the orbits, or we call energy shells. But there are certain rules when we are filling electrons in these orbits. If an atom wants to be stable in nature, if an atom wants stability in the nature, then there are certain rules. And those rules which were given by Bohr are: first is outermost shell should be K and it has 2 electrons. Then it attains inert gas configuration. Inert gases are those gases in which the outermost shell is completely filled and they become unreactive. Or second condition is whatever the outermost shell, but it has 8 electrons. That can be L, M, N, but it should have 8 electrons in its outermost shell. So these are two conditions if to be stable, according to which the atoms can be stable in nature, and these two conditions were given by Bohr. Now first is valency. When we are writing electronic configuration, we are saying to be stable in nature, an atom can lose electron or gain electron. So that tendency or combining capacity of an atom is called its valency. Sometimes it is losing electron and sometimes it is gaining electron. So in both the cases, the combining capacity or the tendency of losing or gaining electron is known as valency. Then we have atomic number. As I told you, in a structure of atom, nucleus is present in the center and electrons are revolving around it in particular orbit. Okay. Now this nucleus composed of protons and neutrons, and electrons are revolving around it. Protons has positive charge, neutrons has no charge, electrons have negative charge. And we know that in an atom is electrically neutral. It means it has equal number of protons and equal number of electrons. So atomic number is always equal to number of protons. So if we are saying number of electrons is equal to atomic number. If these two are equal, so number of electrons a number of protons, or we can say atomic number. Atomic number. So they all are equal. It means number of electrons is equivalent to number of protons, because we know that an atom is an electrically neutral. And how it becomes electrically neutral? Write down in the comment box how an atom becomes electrically neutral. So if it contains equal number of positive charge and equal number of negative charges. So that means number of electrons equivalent to number of protons, and we know that number of protons is equivalent to atomic number. So whatever the atomic number an element has, it means it contains that number of protons and that number of electrons. Then we have mass number. Mass, if you remember, Rutherford told in his experiment, he explained that the entire mass of an atom constrained in the center. It is present in the nucleus, and that nucleus is a combination of protons and neutrons. In nucleus, protons and neutrons are present. So it means the entire mass of an atom is present in the center. So mass number is equal to sum of, remember, sum of protons and neutrons. So mass number is equal to sum of, it means if you are adding number of protons and number of neutrons, then it is equivalent to mass number. So I hope these terms are very much clear to you. Valency, atomic number and mass number. These are very important terms, because on the basis of these terms, there are certain questions which can come in exam. Now, how to find out valency? For that, you need to learn atomic number at least 1 to 20. So if you learn atomic number 1 to 20, how to write electronic configuration according to Bohr model. Now, let's take an example of aluminium. Now tell me, what is the atomic number of aluminium? Write in the comment section. It's 13. And simultaneously write down electronic configuration. I'm writing here. You can write down in your notebook. K, L, M, N. These are the energy shells. And how can we write electronic configuration according to Bohr model? In K, only 2 electrons can accommodate. 8 can come, although more can come in M and N also. 2, 8, 8 and 2 is 10. How many are left? Its atomic number is 13. Only 3 are left, so I'll write 3 here. Now, if an atom wants to be stable in nature, it should have 2 electrons in its K shell, but its outermost shell is M, and it does not have 2 electrons, it has 3 electrons. So in outermost shell, if 8 electrons are there, then it becomes stable in nature. So how it becomes stable? There are 2 conditions. Either it will lose 3 electrons or it will gain 5 electrons. So but we always go for the less number of electrons, because for this losing or gaining electrons, if the number of electrons are losing more in number or less in number, so it required some amount of energy. But if we want to remove 5 electrons from this aluminium, it required tremendous amount of energy, which is not possible for the aluminium. So it is easy to lose 3 electrons, because for losing 3 electrons, it requires less energy. So here it is losing 3 electrons. If it is losing or giving 3 electrons, then it becomes 3 positive. It becomes cation, because it is losing. When any element losing electron, it becomes cation and it attains positive charge. Generally, metals are electropositive because they always lose electrons, and that's why they attain this positive charge on them, and we call them electropositive. So if an element losing electrons, it has positive charge on it and it becomes cation. So valency of aluminium, if I'll write valency, what is the valency of aluminium here? It is 3. And if we are talking about valence electrons, see, valence electrons and valency, there's a difference between these two terms. Valence electrons are the number of electrons present in the outermost shell. So it has 3 electrons in the outermost shell. So its valence electrons are also equal to the valency. It's not necessary that in each case it happens like this. Might be in some cases valence electrons and valency are different. But here it has 3 valence electrons and its valency is also 3. I hope this is clear to you how to write electronic configuration. Now next is, let's take an example of magnesium. Its atomic number is 12. Then how we'll write its electronic configuration? It's 2, 8, 2. Okay, now again it has 2 electrons. Now if I'll ask what valence electrons, how many valence electrons it has and what is the valence, what will be your answer? It has 2 valence electrons and its valency is also 2. Fine. Now I'm giving you a few questions and tell me their electronic configuration and valence electrons and valency. Okay. Now I'll give you chlorine, then potassium, and sodium, oxygen, and nitrogen. Now write in the comment box whether they are electropositive or electronegative, or what kind of charge do they have and how we'll write their electronic configuration. So let's see these metals and non-metals. Few of them are metals and few of them are non-metals. So how can we write their electronic configuration? Let's do all these elements one by one. First is chlorine. Its atomic number is 17. That's why I'm saying you have to learn their atomic number. Otherwise, you'll not be able to write their electronic configuration. Now, just write down its electronic configuration is 287. Okay. Now, let's see here valence electrons and valence. If you remember, I told you that it will not happen in all the cases that valency and valence electrons are same. So here is an example. Here 7 electrons are present in the outermost shell and it means valence electrons are 7. But to attain stability in nature, to attain inert gas configuration, this chlorine accept 1 electron. So here it is accepting 1 electron. So that's why its valency is 1 negative, because it is accepting. So when we are writing valency, it is 1 only, or sometimes we write like this. The valency of chlorine is 1 because here it is accepting 1 electron and it becomes anion. Fine. Now let's come to the next one, which is potassium. Potassium atomic number is 19. Potassium atomic number is 19. KLMN. So how will you write its electronic configuration? 2, 8. First we will fill first energy shell, then only we'll jump to the next one. So here first we are filling K shell, then we'll jump to L shell, and once it is completely filled, then we can move on to M. Now we can move on to N. Okay, so it's valence electrons 1 and valency is also 1, because here it is losing one electron and it becomes K positive. It becomes cation. Understood? So this is how we'll write electronic configuration of different elements. Next is sodium. Its atomic number is 11. I hope you are solving it simultaneously. KLMN. And those who knows the answer, please write down in the comment box. 281. So here, if we are talking about its valence electrons, 1 and valency is also 1, because here it is also losing one electron, it is giving one electron, and it becomes positive. Again, it becomes cation. Now let's see this example, oxygen. Its atomic number is 8. KLMN. First we'll write all the energy shells, then we'll fill electrons accordingly. I'll write 2 and 6. So to be stable in nature, it needs 2 electrons, but it cannot lose 6 electrons. So here valence electron in this case is 6 and valency is minus, because here it is accepting 2 electrons and it becomes O2 minus. Now let's move on to next one, which is nitrogen, and its atomic number is 7. We'll write its electronic configuration 2 and 5. So here it needs 3 electrons to complete its octet. Here valence electrons 5 and valency is 3. Here it is accepting 3 electrons. This 3. Understood? So how these elements exist in nature? If they want to be stable, for their stability, either they lose electron or gain electrons. According to that losing or gaining electrons, it decides their valency and charge is present on them. So I hope this is clear to everyone. Now let's move on to this table. As you can see in this table, elements are present. These elements, they are arranged according to their atomic number. As I told you, atomic number is equal to number of electrons and number of protons. So here hydrogen, number of electrons 1, because its atomic number is also 1. Then second is helium. Then third we have lithium. Fourth we have beryllium. Fifth boron. Sixth carbon. Seventh nitrogen. Eighth oxygen. 9 fluorine. 10 neon. As you can see now in this neon, see in outermost shell 8 electrons are already present. That's why we call it inert gas. This neon is an inert gas. And these inert gases we are using in fluorescent bulbs also. Then we have sodium, then magnesium, aluminium, silicon, phosphorus, then sulfur, chlorine, argon. Now again let's see argon. Its outermost shell is completely filled and it also has 8 electrons. So it is also an inert gas. Then we have potassium, which is 19. then calcium, which is 20. Fine. So these are the elements which are arranged according to their atomic number, and these are their symbols. How can you represent them? And this is the electronic configuration. These shells are K shell, L, M, and N. And this is electronic configuration of these different elements. The number of protons, or you can say number of electrons or protons. They both are equal. So I hope till here it is clear to you. So you need to learn this entire table, and if you learn this atomic number, you can easily write their electronic configuration. And if you know their atomic number, you know the number of electrons and number of protons in them. Because in sometime in question, in exam, question can come. This, for example, lithium. Lithium element whose atomic number is 3. So write down it number of electrons and protons present in it. And the answer is also 3, because number of electrons and protons are equivalent to atomic number. So if you know their atomic number, you can easily tell how many electrons and protons are present. Now, question can come in exam. Write the distribution of electrons in carbon and sodium atom. Distribution of electrons means you need to write their electronic configuration. So how will you write? Z is the atomic number. Atomic number represented by this symbol. Atomic number is represented by Z, and mass number always represents by A. So here write the distribution of electrons in carbon and sodium atom. So first is carbon, whose atomic number is 6. And if we'll write their electronic configuration, either you'll write your answer like this, or you can simply write like this, 2 or in this manner also you can write the electronic configuration. Then we have sodium. Again, its atomic number is 11. See here in this question, no atomic number is given. So that's why I'm saying you'll need to learn their atomic number. And this entire electronic configuration is based on their atomic number only. KLM, it's 2, 8, and 1. Or you can write electronic configuration. So this is the distribution of electrons in different energy shells or in the different orbits. Then question number 2. If the K and L shells of an atom are full, it means question is if K and L shell are completely filled. So in K shell, maximum 2 numbers can come, or 2 electrons you can say. In L shell, maximum 8 electrons can accommodate. Now, they are saying if the K and L shells of an atom are completely filled, means 2 is present here and 8 is present, then what would be the number of electrons in the atom? Simply you need to add these two. Answer is 10. Which means it has total 10 number of electrons present in that particular atom. Now next is mass number or atomic number. As I told you, mass number is the number of protons and number of neutrons present in an atom, which is present in the nucleus, and that nucleus is present in the center. So this mass number is represented by this A alphabet, capital A, and atomic number we can represent it by Z. An atomic number is equivalent to number of electrons and number of protons. So if we are representing mass number and atomic number of any particular element, so we can write like this. Here you can see if you are writing C, 6 and 12. So here C, 6. So this represents atomic number. atomic number. So whenever we are writing any number just below this element, it represents its atomic number. And when we are writing mass number, we always write mass number on the top. So here we can represent mass number and atomic. So this number shows mass number. For example, in sodium, you can write like this. So this is the mass number. This is atomic number. Fine. Now, this is how we can represent mass number and atomic number in an element. So there are certain formulas which you keep in your mind when you are solving a few sums. Like mass number, which is denoted by this A, is equivalent to number of protons and number of neutrons. This, we are talking about this number of protons and neutrons. This is nucleus, which is in which neutrons and protons are present, and this nucleus is present in the center. So it is equivalent to mass. Now number of protons is equal to number of electrons and atomic number, or we can write number of protons is equal to atomic number or number of electrons. So these all are same. Then we have number of protons. If you need to find out number of protons, from this formula you can easily find out number of protons is equal to mass number minus atomic number. Okay, mass number minus atomic number, number of neutrons, not protons. This is number of neutrons. If you need to find out, write again here, number of neutrons. So formula for this is mass number minus atomic number. So these are the certain formulas which you keep in mind when you are solving numerical problem. Now, what kind of question can come in exam? Just take a look. Find the element mass number whose atomic number is 18 and neutron number is 20. So, number of protons is given, which is 18. Atomic number is equal to this number of protons. Now, number of neutrons is given 20. You need to find out mass number. Atomic mass is equal to number of protons plus number of neutrons. Number of protons is 20 and number of neutrons is 18. You will write just by adding both the numbers. Okay. Now next is helium atom has atomic mass of 4U. This U is the unit of atomic mass, which is unified mass, or we can write atomic mass unit, AMU, and has 2 protons in its nucleus. How many neutrons does it have? It means helium atom has atomic mass of 4U. So it means mass number of helium is equal to 4. Okay. And protons, so number of mass number is 4. So number of protons in the nucleus is 2. So its atomic number is also 2. As we know that protons is equal to electrons is equal to atomic number. So if proton is 2, electron is also 2, atomic number is also 2. We need to find out number of neutrons And formula for this is mass number minus atomic number. Mass number which is given 4 and atomic number is 2. So by subtracting these two numbers, we'll get 2. The number of neutrons present in helium atom is 2. Fine. Now one more question which can come in exam. Sometime in exam this can be written. Suppose an element is represented by this symbol. What information you will get from this formula? You need to write all the details which you will get from this formula. If you are looking at this, you will get an idea that the number which is written above, that represents mass number, and the number which is written below, that represents its atomic number. So what information do you get? We'll get like atomic number is 11 and mass number is 23. Number of electrons 11, because atomic mass, atomic number and number of electrons, they both are equivalent. Again, number of protons, that is also 11, because this one and this one, they all are equal. Then we have number of neutrons. Now with the help of formula, we can easily find out number of neutrons. Atomic number, mass number is 23 and it is 11. Answer is 2 and 1. So it has 12 number of neutrons. I hope you can easily write the information if this type of question can come in exam. So how will you write atomic number, mass number, number of electrons and number of protons? Or you can easily find out number of neutrons as well. So these kind of question can come in exam. Or sometime question can come, find out number of electrons in a given element. Suppose they'll give you question, suppose an element whose atomic number is 20. Okay. Now they are asking, write down the number of electrons and protons present in them. If the atomic number is given, you can easily write number of electrons, which is also 20, and number of protons. So fine. So question can come in any form. So might be they'll ask like this, which I have just discussed with you, or they'll give an element, or it will represent by any alphabet, then they'll give mass number and atomic number. So you need to find out any of this, or you'll write all the information you'll get from this representation. I hope these kind of questions are clear to you. These are extremely important questions. Generally, these questions can come in exam in 2 marks. So you need to learn all the atomic numbers of elements at least from 1 to 20. Only then you'll be able to write. Generally, mass number is always given in the question. Now we have certain type of special substances present. We call them isotopes. The isotopes are those elements, they have same atomic number but different atomic mass or different mass number. See, examples are given. If you look at the example of this carbon, carbon exists in nature in different forms. So here you can see the atomic number is same, it is 6. But if you look at their mass number, it has 12 and it has 14. So when they exist in nature in these isotope forms, they have different chemical properties also, but their physical property is same. How they look like, what texture do they have, so their state that is same, but their chemical properties are different. So on the basis of their property, we can use these isotopes into different ways. Like an isotope of uranium used as fuel. Uranium also exists in 235 or 238. It exists in nature in two forms. An isotope of cobalt we can use in the treatment of cancer. Then we have isotope of iodine, which we used in the treatment of goiter. So these are the different isotopes. Another example of isotope is hydrogen. Hydrogen exists in nature in three different forms: H11, H12, H13. Here you can see their mass number are different, but their atomic number is same. So in this form, we call it hydrogen. Then we call it protium, or we call it deuterium, or we call it tritium. So these are different isotopes of hydrogen in which their atomic number is same but mass number is different. So on the basis of that, we can use them in different form. Now, isotopes of oxygen. Oxygen exists in nature in 16, then we have 17, then we have 18. So these are different isotopes of oxygen. Chlorine, if we'll take an example of chlorine, chlorine can also exist in nature in two forms, 35 and 36. These are the mass number of chlorine. So these all are isotopes in which you can see in all the examples their atomic number is same but their mass number is quite different. Then we have isobars. Isobars are opposite to that of isotope. So isobars, it means their atomic number is different but their mass, atomic mass, or their mass number, sorry, it is same. As you can see, calcium and argon, their atomic number is different, it is 20 and it is 18, and but their mass number is same, which is 40 and 40. Or now these are isobars. Fine. Now question can come in exam, or I'll just tell you one more thing. Easy way to learn. This is same atomic number, different atomic mass, Sandam. Or you can learn isotopes, same atomic mass, different atomic mass. So these are the simple way to learn. Now questions can come in exam. Do isobars have also identical chemical characteristics like isotopes? No, because if you are talking about isobars, only their atomic number is same, but their mass, sorry, their atomic number is different, but their mass number is same. But if you are talking about isotopes, they have different atomic masses, but their mass number. So these are the examples of different isotopes and isobars, and they have different electronic configuration. Next is which radioisotope is used for the treatment of cancer? It is cobalt-60. Out of C12 and C14, these two are the isotopes of carbon, which is of radioactive nature. Carbon-14 is radioactive in nature. These kind of questions can come on the basis of isotopes and isobar. In next class, I'll discuss few important questions from this chapter. This is end of the chapter now, and we have done these topics today. Please revise all the topics which we have covered so far, and as I told you, learn the entire table in which the atomic number is given. This table. This is extremely important table, and learn all the number of electrons, or you can say atomic number 1 to 20 at least. Then only you will be able to write their electronic configuration and tell their number of protons and electrons present in. So I hope till here it is clear to you. And for your question, you need to write